Hey guys, this is another question that is really good for visualizing and conceptualizing the mole, just to make sure that you understand it. So this is from the revision sheet that I handed out to my class today. And what we have here is a question. The largest number of oxygen atoms would be found in which of these possible solutions? So what we need to do is work out the number of oxygen atoms in each one of those. Okay, so there's no good comparing mass to moles, to grams, to atoms. We need everything in the same units. Okay, now like I've mentioned before, when you get a mole question, the easiest thing to do is to convert everything to moles and then work from there. So that's what we're going to do now. We will work out how many moles there are in each of these options, and then we'll be able to compare to see which one has the greatest number. So let's do these one at a time. So in part A, let's look at part A. Whoops. Okay, so part A. We have 300 grams of water. 300 grams of H2O. Okay. Now, what we want to do is work out the number of moles of H2O we have. Remember, the first thing we want to do is find out how many moles. So to do that, we need this formula. Lowercase n is equal to m on m. Okay, so you should all remember that. That's the formula you absolutely need for this. So n is our number of moles, m is the actual mass we've been given, and capital M is the molar mass. So in this case, our actual mass of water in the question is 300 grams. Our molar mass, so the molar mass of water, is 18. Now you should be able to remember that. There's two hydrogens, each of those weighs 1, and there's an oxygen weighing 16. So the total mass, the molar mass of water is 18 grams per mole, and if we work this out, we get 16.67 mole. So we have 16.67 mole of water. Okay, that's what that equation gives us. N is the number of mole. So in 300 grams of water, there's 16.67 mole of water. Now, as you'll notice from the formula for water, right here, each molecule of water has a single oxygen atom. Therefore, if we have 16.67 mole of H2O, we must have 16.67 mole of oxygen. So this is our answer to part A. We have 16.67 mole. Now, part B. We want to work out the number of mole in part B as well. Let's do part B over here. So in part B, we have 3.2 mole of hydrated copper sulfate, CuSO4, 5H2O. Now, the good bit is, the first part that we did in part A, N equals M over M, we don't need to do that because we know just from the question that we have 3.2 mole. Okay, so all that calculation where we had to calculate the number of mole of water in part A, we don't actually need to do that for copper sulfate because it tells us we have 3.2 mole of CuSO4, 5H2O. Now, we're not finished though. What we do need to be aware of is that for every molecule of copper sulfate, okay, inside every molecule, there are 4 oxygen atoms there and 5 there. So we've got 5 H2Os. So, 5 H2Os means we have 5 oxygens there, and this O4 means we have 4 oxygens there. So we have 9 oxygen atoms in total in every molecule of copper sulfate. Okay, so we know we have 3.2 mole of copper sulfate. So to find the number of oxygen atoms in mole, we just do 3.2 multiplied by 9. Because, as I said, we've got 9 oxygen atoms in every molecule of copper sulfate, and we have 3.2 mole of those molecules. So 3.2 times 9 will give us 28.8 mole of oxygen atoms. Okay, so already, part B, we have more oxygen than we do in part A. So we know that the answer can't be part A. Okay, it can't. There's more oxygen in 3.2 moles of hydrated copper sulfate than there is in 300 grams of water. Okay, so let's keep going. So let's just underline this so we know that that's what we're looking for. Let's do C over here. So 3 kilograms of the fat having a molecular formula C17H110O6. All right, so again, we're going to need to use our... Whoops, that's not right. N equals M over M. We need to know how many mole of this fat we have, how many molecules of this fat. So we need this formula. Now, in the first case, the actual mass we've been given is 3 kilograms, but we always want that in grams. So we've got 3,000 grams is our actual mass. Now, our molar mass, this is going to take a little bit of working out, because the formula C17H110O6, we need to work out the mass of all of that. C17 is equal to 17 times 12. So each carbon weighs 12, and there are 17 carbons. So that will give us 204. Now, for the hydrogens, there's 110 of those. Each one is worth 1, so the hydrogen weighs 110. Our oxygen, there are 6 of those, so there's 6 times each oxygen weighs 16, and that will give us 96. So if we add up this, this, and this, we'll get the total mass for one molecule of this fat, which is, the molecule is equal to 410 grams per mole. Okay, so back up to our equation, 3,000 divided by 410. Now, okay, so 3,000 is our actual mass, 410 is the mass of our molecule. If we work this out, put it into a calculator, you'll get 7.32 mole. So we have 7.32 mole of molecules of that fat. Okay, so 7.32 times 6.02 times 10 to the 23 molecules of that fat are in 3 kilograms. Now, the other thing to be aware of is in each one of those, in each molecule, we have 6 oxygens. Okay, so if we have one molecule, we'll have 6 oxygen atoms. If we have 2 molecules, we'll have 12 oxygen atoms. So if we have 7.32 mole, the number of oxygen atoms will be 7.32 times 6, okay, because each molecule contains 6 oxygen atoms. Okay, now, if we work this out, we will get 43.9 mole. So we have 43.9 mole of oxygen atoms in that amount of fat. So let's underline that as well. Okay, finally, part D. We're getting there. Nearly finished. Part D. We want to know how many oxygen molecules there are in nitrogen dioxide. So again, first thing we want to do is work out how many moles there are. To do that, this is a little bit different this time. But this is how many molecules we have. If we divide this by Avogadro's number, that'll tell us how many mole of nitrogen dioxide we have. So if you put that into a calculator, you'll get 12.2 mole. So we have 12.2 mole of nitrogen dioxide. Okay, now, again, we need to be aware that in nitrogen dioxide, for every molecule of NO2 we have, there are 2 oxygens. Okay? So, if we have one molecule of NO2, there are 2 oxygen atoms. If we have 2 molecules, there are 4 oxygen atoms, and so on. So to find out how many oxygen atoms there are in total, we do 12.2 multiplied by 2, which will give us 24.4 mole of oxygen atoms. So we've got our 4 solutions. So in part A, there are 16.67 mole. In part B, there are 28.8 mole. In part C, there's 43.9 mole. And in part D, there's 24.4 mole. So we can see from this, part C has the greatest number of oxygen atoms.